All right, so we've got evidently we got we got the magnet and the coil going on again here, right? And the spring, we got this thing oscillates up and down like this, right? The ends of the coil are connected to a sensitive high resistance voltmeter. The bar magnet is pulled down, so the north pole is level with the top of the coil. The magnet is released in the variation with time, so it moves upward. Notice this is the velocity, right? So it starts with zero velocity. It accelerates to some maximum velocity, at which point it slows down and stops, right? And this, by the way, is when it's the farthest from the coil. Then it moves toward the coil, reaches some maximum velocity, then gets back to just even with the coil, and it's stopped for a moment, and then it starts to go away from the coil. Here it's at a maximum distance from the coil, and it stops, right? So that's what's going on here. Is it's oscillating back and forth here, right? Mark a letter M, one point in the motion where the reading is a maximum. Well, remember that the EMF is going to be minus N. That's the number of windings here, right? Times the change in flux. So change in flux over change in time, right? So this is going to be a maximum when the flux is changing at the maximum rate. The flux is changing because of the velocity of the magnet. So you need to put an M where the velocity is a maximum, okay? And then Z is where it's going to read 0. 0 is when this velocity is 0. So mark on that graph one spot where there's a 0 velocity. I think you can do it, okay? And then B, explain in terms of changes of flux linkage why the reading on the voltmeter is alternating, right? Well, talk about as that north pole approaches and recedes, right? The flux is either increasing or decreasing, right? Increasing flux gives us one direction, decreasing gives us the other direction of current, okay? I think you can do that. Flux. All right.